See, we are going to discuss the effect of depth on the gravitational acceleration. Okay, here we are discussing with respect to Earth now. So let's say the density of Earth is rho, radius of Earth is re, and mass of Earth is me. Now there is a particle on the surface of Earth. Okay, here on the surface, the gravitational acceleration I am writing g. Okay, on the surface, so it is gs. So right now we have written the equation. The gravitational acceleration on the surface is minus 4 upon 3 pi rho capital G into radius of the planet. Now we want to see the effect of depth. So suppose from the surface we are moving inside the earth at depth d. Now particle is somewhere at depth d, and here gravitational acceleration I am writing g subscript d. Distance of this particle from the center of earth, that will be now re minus d. So now for depth d inside the earth, gravitational acceleration is g subscript d, and radius for this particle will be re minus d. So can we write gravitational acceleration at depth d equals to minus 4 upon 3 pi rho g then re minus d. Yes or no?
Yes, sir.
Okay. Now just dividing these two equations, gravitational acceleration at depth d divided by gravitational acceleration on the surface. So minus 4 upon 3 pi rho g will cancel. So it will be re minus d divided by re. Okay. Now simply we can write this as 1 minus d upon re, and this is gd upon g. Further we can say gravitational acceleration at depth d equals to gravitational acceleration on the surface 1 minus d upon re. So this minus sign over here in the right hand side, 1 minus d upon re, that simply shows us that at depth d the gravitational acceleration will be less as compared to the acceleration on the surface. So as we move down inside the earth, gravitational acceleration will decrease.